Okay, so we're looking on page 603. Problem number 27. Now this one combines a couple of things. Well, one thing that we didn't go over, and a couple of things that maybe you could have came around to. This we have a circle, and we're only filled up not even halfway. And this circle has a radius of 2.4 meters. Yep. And there's a height here of 0.42 meters. And you're asked to find the area of this piece down here. Basically, it's called the area of a segment is what it's called. First step we have to do whenever we're dealing with part of a circle is to find the area of the full circle. So let's do that. Area of this full circle is going to be pi 3.14 times 2.4 squared. So we get 18.09, we're going to call it. Now that is the full in square meters. That is the full circle. Now what we're going to do is we're going to find the area of this sector of the circle, this wedge of the circle here. And the way we can find that is we were told this is 160 degrees. Well, how much is a full circle? How many degrees? 360. So what we are finding is 160 3/60ths of the full circle. We did half circles and quarter circles before. This is somewhere in between, where it's the number of degrees over 360 tells us what fraction of the circle it is. So we'll take that 18.09 times 160 divided by 360. 8.04 square meters. So that's this red pi wedge. Now is where we have to use that strategy where we subtract a piece out. We're going to subtract out this triangle here, which this is 2.4 here. This is 0.42. Are those the dimensions we need to find its area? No, to find the area of a triangle, we need the base and the height. We need two dimensions that are perpendicular. We need this one down here. How do we find it? Now, did you guys do Pythagorean Theorem at all last semester? A squared plus b squared equals c squared? No. No? Okay. So that's one we need to look at. So we call it sides A and B make the legs of a triangle. Okay? On a right triangle, there's two sides that make the right angle. Those are the legs. Those are sides A and B. Side C is the hypotenuse. That's the side that does not touch the right angle. It's the longest side of a right triangle. We have a rule that states that the length of side A squared plus the length of side B squared is going to equal the length of side C squared. So we don't have side A, so that's just going to be A squared. Side B is 0.42, so that would be 0.42 squared. Equals side C is 2.4. So it's 2.4 squared. So it's A squared. What is 0.42 squared? 0.764, or 1764, right? 2.4 squared is 5.76. Now what? We're going to subtract 0.1764 from both sides. And now, of course, having to keep a significant digit. I'm just kidding. Sorry. Couldn't resist saying it. Anyway, we probably should just round this off to 0.18 to subtract it to make it easier. So this is 5.58. I was expecting more of a reaction when I brought up significant digits. I couldn't keep a straight face.
We're not happy with those.
I figured you were. So anyway, it's A squared equals 5.58. So we want just A, so we're going to have to square root. Square root of 5.58 is 2.36. So this is 2.36 here. So what that means, we have two triangles like this. Because remember, there's another one on the other side over here. So we have 2.36 times 0.42 divided by 2 because it's a triangle, but then times 2 because there's a second one of them. So basically it's just 2.36 times 0.42, which is 0.9912 or 0.99 that we're going to subtract from this. So it's 7.05 square meters. Is that what the back of the book was saying? Okay. Yep. Any questions? You having fun yet?
Why do you divide by 2?
Because it's a triangle. So the full rectangle would be the 2.36 times 0.42. So you divide in half to get the triangle. And you have to multiply by 2 to get, because there's 2 of them that size. Because we did this one, but you also got one over here. 0.99 is what it came out to when you divided by 2 and then multiplied by 2 again. It came out to 0.99 square meters. So then it was 8.04 minus the 0.99 give us 7.05. That was a pretty ugly one to start off the first day's or second day's homework with. Any others you want me to go over? We're good? 19. Yes. There it is. Find the unknown area, major axis or minor axis of each ellipse. Okay. Ellipses we don't use a lot, but the area of an ellipse is pi times a times b. This is really the same formula as for a circle, except in a circle, you just have the radius. And the radius is the same no matter what direction you go. So pi times radius is just pi r squared. In an ellipse, you have a dimension A and a dimension B. And I don't remember which one they call. The major is the longer one and the minor is the shorter one. I don't know which one they call A and B in this book. But either way, you can see all it is just the equivalent of the radius for the ellipse. So in like part 17 there, the area is just going to be 3.14 times the 27 times the 19. For number 19, we've got to work backwards. We know the area, which we'll fill in as 1720. Pi is still 3.14. We'll let A be the major axis, which is 54.6, and we're looking for B. So to solve this, what we're going to do is we're going to take the 1720, and I tend to use the easiest way to solve it. You could multiply the pi and the 54.6 together and divide by it all at once. I'm just going to do 1720. I'm going to divide by pi, divide by 3.14, then I'm going to divide by 54.6. And I get 10.03 has to be B. Does that make sense?
Not what I got.
Is that what the back of the book said?
I don't know. 19?
Let's see if I screwed up my calculation somewhere. Better grab a wrong number. 40.1 centimeters. 1720 divided by 3.14. Divided by number 19, yeah.
You want 17.
No, 19.
Yeah.
19 is
19 is 40.
90 should be 10.03. I get the same answer again. So that's what it is. They're giving me the full axis. They're not giving me the semi. They're not giving us the semi-major and the semi-minor axis. They're giving you the full major and the full minor axis. So this would have been wrong. It should have been 13.5 and 9.5 because that 27 is the full distance across. You need half of that. So for number 17. So for number 19, it's still the 1720. That's not affected. And it's still 3.14 for pi. But instead of 54.6, you need to divide that in half to make it 27.3. And then you're going to find B from that. And B would come out to be 20.06. And that's B. And then you have to multiply that by 2 to get the full axis, which would be 40.12. I should have read closely instead of... I kept seeing semi-major and semi-minor instead of major and minor. Sorry about that. Any others? Okay. Well then, for today, we want to start talking about volume. The way I define volume is a little bit different again, rather than just giving you... The book gives you formulas. If you want to look them up and memorize them or whatever, you can. But you don't need formulas for volume. We defined an area to be a length or a distance that has been pulled through space. And that the amount of space that it traces out on the ground is its area. It's that length times some sort of a movement, a distance, which we call that distance a width. A volume is the same thing. A volume starts out as an area. So imagine this is an area sitting on the ground, and you're just kind of looking at it from above at an angle. To create a volume, we take that area and we pull it through space. And the amount of space that it displaces is its volume. So a volume, the size of a volume is equal to the size of that original area times some sort of a distance that it's moved. And that distance is normally called a height. So for a box, the official word for a box, by the way, is called a rectangular prism. You don't necessarily need to memorize that, but the book will say the word prism. All that is you have a shape on the bottom, you pull it up to the top, and that makes the solid object. So anyway, this rectangular prism or box, let's say that this is 12 inches by 10 inches by 5 inches. We start out by finding the area of the base. Now on this, the base could actually be any side. We tend to use the bottom. So the area of the base is 12 inches by 10 inches, or 120 inches square inches. So then the volume is found by taking that area, 120 square inches, and multiplying by that height of 5 inches to give us 600. Square inches times inches is inches cubed, or inches to the third power. Now, many of you were taught the volume formula for a box. It was length times width times height. What we did here is just exactly that. Length times width is just the area of the base. Then times the height, like we did here with the 5. The reason I define it to be the area of a base, the volume is the area of a base times the height, is because this formula applies to shapes other than boxes. The length times width times height only applies to boxes. So for this one, it's not a box, it's a wedge. And for this one, the base is not the bottom. On the box, we usually use the bottom as the base. But it doesn't have to be. The base is the one side of the solid object that you can grab onto and you can pull through to make the object. Does that make sense? If you cut that object at any place, you'll have that same shape as what the base is. So here, let's say we have 5 inches, 12 inches, and 20 inches. The area of the base is just a triangle. So it's going to be 5 inches times 12 inches It's a triangle, so we have to divide by 2. That's going to be 30 square inches. That's the area of the base. So the volume will be that 30 square inches times, now the height doesn't go up and down anymore. The height is the distance between the bases, so that would be the 20. So 30 square inches times 20 inches, 30 times 20 is 600. Square inches times inches is inches to the third, inches cubed, cubic inches. So you can see by having that area of a base times a height, I don't need a new special formula to do a wedge. Or, pretend those circles are approximately the same size. A cylinder. The volume is just the area of the base times the height. Well, the base on this is a circle. So the area of the base is going to be pi times 4 squared, which is going to be about 50.24 square feet. So then the volume will be that area of the base, 50.24 square feet, times height of 10 feet. 502.4 square feet times feet is cubic feet, or feet cubed. What do you think? Anybody like lost? You guys feel like you could try some of these? Okay. Out of the book. Page 615 through 616. 1 through 15, if you just want to do the odds, that's only 8 of them, so it shouldn't be so bad. I'll go a little bit easier on you than I did the last couple days.